Okay, so let's run through a few of these. Number one, really, you know how to do all of these. You actually knew how to do them before you came to my classes here. There was just one extra detail that we added on that I squares cannot be left from your answer. So 3i and 8i, you should have already known how to do that last year, or even like in something. 3i and 8i is 24, 3 times 8 is 24, I times I is I squared. Now this year, we talked about imaginary numbers. We cannot write I squared. I squared is actually a real number. It's -1. So this is 24 times -1, which is -24. Or essentially, you could just change the sign of the 24 and wrote it to -24. Okay, let's look at number 2. There are 3 things here being multiplied. Let's take 2 of them at a time. The first 2. Meaning, what is -I times 3i? Good. -3i squared. And then this 2i, we're going to use it at the very end. Just going to tag along. Just take 2 of them at a time. Take a roll in any order. Just going to start with the first 2. Once my square pops out, you should automatically change that. What is my square's value? -1. So this is -3 times I squared. So we need to change it to -3 times -1. If this is the right color. Times my 2i. Still going with the first 2. Just see, we can still multiply those, right? The first 2. What's their product? Good. The negative times negative is a positive. So positive 3 times 2i. Okay, we're finally done with the first part. Now we can times by 2i. Okay, Sebastian wants the 3 times the 2i. 6i. Should I change this I to -1? Only I squares to -1. Only I squares. Okay, so we have 3 of them. Let's take the first 2. Okay, turn to your table, please, and tell them what -4i and -3i is on the first step. Don't do the last step, the first step. Turn to your neighbor and tell them the first step. What do you get on the first step when you multiply? -4i and -3i. Just the first step. Okay, Riley? What is -4 times -3? So negative times a negative is a positive 12. And Riley, what is I times I? I squared. Good. So we get 12i squared. Is this good for my answer? No. We need to change it. Rachel, what do we need to do for that? What have we done with all those other problems? The I squares. This is 1. It's -1. So this is 12 times -1, which is just -12. You only get the I squared when you're multiplying. When you're adding or subtracting, you're not going to get the I squared unless you start with an I squared. You can see all the ones below, adding and subtracting, there's not an I squared to start with. So let's try number 5. You can do number 4 probably super quick. Number 5. Now this, -6i plus 7i. -6 plus 7. Good, right? -6 plus 7 is 1, right? And the -6 ice creams plus 7 ice creams would be 1 ice cream, or 1i. So we don't need the calculator right now. Let's put them down. Okay, you can use the answer of 6 in 2 seconds. Your answer, 4 and 6, they should be done in like 2 seconds. 7i plus I, that's your answer. Okay, number 7. There's a tricky part. They're all paying attention on number 7. If you don't pay attention, what are you going to miss? Yeah? Yeah, it's a real number, but it's a real number. Is it 1? It's what? -1. Where's the -1 in this? Number 7. In front of the that. I'm laying in front of the parenthesis. When you're minusing, you're not just minusing the 1, you're minusing both of them. It's distributive property. First, we need to change the sign. Instead of a 1, if we're minusing a 1, it becomes -1. And minusing a negative for I becomes positive for I. So it can be tricky. If you see it with subtraction sign in front of parentheses, you need to distribute it in first. Now how do we add? I'm good. You guys know how to do this since X history. But, like terms, combine like terms. So we're going to go with the real pieces first, and we'll the real piece written first, and then the imaginary piece second. Okay, you guys keep yours in the air. What's the real piece? There's a pie in the air. What's the real piece? We have negative I, we have -1, and we have positive 4i. What's the real piece? -1. The only one without an I, right? That's the real piece. -1. The extra I, so they're in the imaginary family. We need to add those up. -8i plus 4i. We have to change the sign. Okay, Rosie, it's -8i plus 4i. Good. -4i. This is going to take in the right order because we have the a plus the I order with the real piece first plus the imaginary piece second. That's our standard form for complex numbers. Okay, we're going to go to number 8 on your worksheet. Make sure the answer is written real piece first, imaginary piece second. Yes, Johnny? Okay. Later on that, we're going to flip ahead to the other part on complex is further down. Number 17 is when we see complex again. We're going to number 17. Guys, here's a hint on your test. You don't have to do the test in the order it's written. Right? Do you know what we're going to do first? So get comfortable with what we're doing right now. Small of the puzzle I's first. Draw complex puzzles first. And then go back to the next thing you're comfortable with. Okay. Find the absolute value. Absolute value of each complex number. You've also known this formula since last year. You use it a lot. Does anyone know the definition of an absolute value? What is absolute value? What does that mean? Oh, okay, we talked about this. What's the absolute value of 4? 2. No. What's the absolute value of 4? No. What's going on? What's the absolute value of 4? 4. What's the absolute value of -4? 4. They're both positive because they're equidistant from which number? 0. Absolute value is distance from 0. So in this case, this is a two-dimensional graph. Our absolute value is distance from the origin, which is where 0 is. If you look at the graph below, there's a hint of what the x-axis is called. The graph below, what's the x-axis? Real, what's the y-axis? Imaginary. So this is real. Real counts by 1, 2, 3, 4, 5, 6, 7. That doesn't count by 1, 2, 3, 4. What does it count by? 1i, 2i, 3i, etc. So it's a imaginary axis. We're drawing this so we can remember how the absolute value is formed. And how to graph it. Because on other problems you have to graph. It's graphed the same way. We do our x first, which is a real, which is horizontal movement first. And then the y, which is imaginary, is a vertical movement. So it's just the same as our normal ordered pairs. First we go horizontally, second we have vertical movement. All start at the origin. Caitlin, can you tell me how much you move away from the origin to graph 6 plus 2i? Right, 6 up 2. That makes sense because they're positive. Right and up is positive. Left and down is negative, just like your normal mapping. So that's the point 6, which is no comma. 6 plus 2i. Now distance from here, I would if I connected those two. That's what we're finding. Absolute value is that length. Well, if I also drop down perpendicular to the real axis, it creates a right triangle. That blue line, our distance is what part of the right triangle? Has a name. The long side of the right triangle. What is it? Hypotenuse. How do we find hypotenuse on a right triangle? The a squared plus b squared equals c squared, which is named, I put the name over here, Pythagorean theorem. A squared plus b squared equals c squared. That's a theorem you should know from last year. A, B, or C. Can see that in the end? Which one is the hypotenuse? Show up. A is the hypotenuse, B is the hypotenuse, or C is the hypotenuse? Which one's the hypotenuse? A, B, or C? Which one's the hypotenuse? Question, Rachel? We're confused. A, B, or C? One of those letters is the longest side of the rectangle. Okay. C. It is. So, we can solve for C. We know A and B. Doesn't matter which is which. One of them's 6, one of them's 2. Doesn't matter which is A, which is B. Just plug them in. Here's parentheses in case of the negative, though. 6 squared plus 2 squared. Or you can do 2 squared plus 6 squared. It doesn't matter the order of those two. Equals 2 squared. Don't just have another calculator. We can do this without a calculator. When we're simplifying, we follow PEMDAS. What do I have to do first? Well, there's something in the parentheses. So next comes exponent. 6 squared. Moving with that. 6 times 6, there you go. 36. Plus, let's see what's 2 squared. Good. 4. That equals 6 squared. You don't want to see those yet. That's what we're trying to find. Now we can add them. 36 plus 4. 40 equals c squared. Are we done? Right, because we don't want c squared. We want c. So it's square root of them. C equals the square root of 20. But, just like we did last time, whenever you have a square root, you must check and see if it's simplified. I know square root of 20 is not perfect. It's not perfectly because square root of 36 is 6 times 6, and 7 times 7 is 49, so skip it. If you put the clear calculator the decimal, do not write a decimal for your answer. We need to calculate, break it down. 8 and 5, 4 and 10, 2 and 20. All these are options that work. Let's use 8 and 5. So circle 5. Remember that trick with the 8s? 2, 2, and 2. So all these ones I've circled, I'm going to encroach on 18's area. I put in parentheses, in square roots. Okay, true. Let me look for now. So I have all of my prime factors that multiply back up to 40 in groups of 2. So I'm going to put 2 and 5 together. I'm going to put 2 and 2. And when I have a group of 2, what number pulls out? So, yeah, 2, not a 4. Lots of people pull out 4. It's not the case. It's a group of 2. It's a group of 2. Do these two match? No, so we come back there. G times 5 is 10. So that's C. And the reason it's only a positive square root and not plus or minus is because distance is only positive. It doesn't make sense to have negative distance. And it is the absolute value, right? Is the absolute value always positive? Unless we're taking absolute value as 0. And that is because it's measuring distance, which is positive. Okay? Number 19 down below. You should know how to graph this now. You can tell me how to graph negative 1, negative 3i. So the first one's x, which is our real, and then we have vertical movement, LA. Left one. Down 3, right there. And first you go horizontal, just like normal graphing, and then you move vertically. So there we go. Alright? Graph number 20. That's all. That should be easy point for you to test graph number 20. First part is your horizontal movement. Second part is your vertical movement. That's the same point on the graph. Yeah, and then 21.2, they have the point, you just have to name it. So first, 21, first you move right or left to get to that point. Move left. How many to the left? What number is that? Negative 3. So you move down to what number? Negative 4. I. So no commas. It's just negative 3, the real part, minus 4i. The complex number in the real, also minus an imaginary. Okay, continue from number 22. First, horizontal movement. Second, vertical movement. Make sure the vertical movement has an eye on it. That we move left. So what's the sign if we move left? So I'll just push negative there and move it. Okay, these are reverse. First you move left, you move up. And the real part has come first. So, no comma, just plus or minus. So since you moved up, is it plus or is it minus? We move up. And then we move up, it's plus. Another. Gotta make sure there's a negative sign as well. Okay, how we just do? What do you get for 22? What do you call it? What comes down? Negative 3, out of the good, everybody said. You agree? I agree. So we move left, which is negative, and then we move up, the goes is plus 4. That's plus 4i, and it's an imaginary axis. Also, there's no comma. Don't put comma. Okay, I think that's it for complex numbers. Any quick questions on complex numbers? Okay, I forgot. And we're going to do our sandwiches, quarter, comma, and square roots. Yeah, so we need to do factoring and square. We're going to start with factoring. It's on the very end. upstairs. Okay, factoring. Number 27, number 28. Okay, make sure you know the difference in the setups. Quadrant formula and factoring have the same setup. Ax squared equals bs plus c. Make sure it's not equal to 0, and that's easy. X equals to 0. And we want ax squared to be positive. See the squared term? A squared is already positive. So it's going to stay. Don't move it. If you move it, it's going to be negative. You want to put other stuff to it. The positive solve is already positive. Okay? Ellie, tell me what we need to do to move everything to where the a squared is. X. So minus x. Both sides, okay? Look what you said. Okay, you're part of it. Well, I'm actually negative 10 plus a squared, because a squared is positive. Okay, we need to know more stuff though. And besides the 10, what else can we move? What else can we move besides the minus 10? So that the right hand side is 0. No, a squared is on the left hand side, that's pretty good there. Because on the right hand side we need to move. So how do we move that? What's the inverse? Positive. 3a. Yeah? Both sides? Plus 3a on both sides. So the right hand side is 0. The left hand side, we have 3 terms. None of them are like terms. We have a constant with no a's. We have 3a to the first power. We have an a to the second power. None of them are in the same family. So you can't combine them, but you do need to put them in order. Okay? And try to look the right order for these 3 terms. And x squared plus bx plus c. Have them in order, and then it's easy. So, plus or minus 3. Always we put plus. Good. Okay, so we want them, this is called standard form. Make sure they're the same power. A to the second power, a to the first power, no a's. Now we just do what? To solve by factoring. Check, check, show. We're going to check, show for a while. Should we get more and more comfortable with it? Okay, this is probably a little new for Anthony C, so he can tell us the labels that we put across the top and on the side. Emily? And not really a times that way. And then over here, we add to B. So for M, B, and C, if we put them in order, so we will then have A, B, and C. So it comes from these numbers. 1 is what's in that. A, B, C. Okay, so now you have the, make sure it's clear. Tell me what should put in this box. What number is the value of A? 1. What number is the value of C? Doesn't matter. Negative 10. And here we're going to be times them. 1 times negative 10 is just negative 10. So we need to look for what number is B. A, B, C. What number is B? So it was A, B, C. That I can do. 3. Okay? Good. So now we start thinking 2 numbers that multiply to negative 10 and add to 3. We can hear neighbor and tell them what you think it is. Hey, stop please, so I can't hear you 3 rows ahead. Thanks. What 2 numbers multiply to negative 10? So 1 has to be a positive, 1 has to be a negative, to 3. Sherry, Anthony, Rachel, and Alex Pepper, we had that big suit. Second and third row over there, talking to each other. One. Okay. Let's see, Allie, what you get? Okay. Do we agree? Yay or nay? I know that sounds very enthusiastic. 5 and negative 2. Do we agree? Yay or nay? Yay. So then we fill in over here our A's. And because it's a 1A, it's just those are ones, those are too easy. Those are base contactors. J equals the base contactors here between negative 10 and 5. Okay, which makes sense when 1 times 5 is 5. That works. Okay, Dora. What's the base contact between negative 10 and negative 2? Negative 2 is correct. Because 1 times negative 2 is negative 2. That works. And when you check your columns, they'll multiply. So, for an empty entity, I guess we'll do it in you, huh? The diagonals create a binomial. A plus 5. The other diagonal, empty over the diagonal B. What number is in here? So A minus 2. This has to be equal to 0. It can't magically not be an equation anymore. It's still equal to 0. You're not done. Factoring then means we apply that property. 0 property to finish solving it. Make sure I have 0 property. Let's do it. Oh yeah, that's the 0 property. Right, so now let's go do A plus 5. No. Equal to, this is called the 0 property. So it's equal to 0. Yep. So in this case, what number plus 5 is 0? What is it? What number plus 5 equals 0? Negative 5. So it's just the opposite sign. Okay, on this one, we take A minus 2 equaling it to 0. Here, what number minus 2 is 0? Positive 2. And then we graph them. Positive 2, make sure you label it. 1, 2, 3, 4. Negative 5, make sure you label it. The problem's wrong. So, you're going to have 2 questions on each method. All of them will say graph. But if you do quadratic formula method and you get a negative square root, what type of solutions do you have if it's a negative square root? And that is where you get 2. Can you graph on this normal graphing coordinate plane? Can you graph in that series? On this plane, no. On this plane, yes. But on this plane, no. So you would say no real solutions. If you get an I and you have to graph it, and you say no real solutions. So it says graph all real solutions. Okay, let's try one more by factoring. Number 28. Is it ready to go and set up? Well, ready to go and set up, ready to go for factoring? What should be equal to for factoring? 0. So what's on the wrong side? What's on the wrong side? The x squared is on the wrong side, or is it the minus 7 that's on the wrong side, or is it the 6x that's on the wrong side? 6x is on the wrong side, because x squared is positive, and we want to move everything to the left. 6x is not on the left. So we're going to try to move the 6x. What's the inverse? Minus 6x. There we go. Both sides. 6x minus 6x cancels. Okay, on the left-hand side, Johnny, can you tell me the order? That's what happened on most of. Let's go order at least 3 terms so that it's set up. Good job. X minus 6x minus 7. Okay, what's the next step? Tic-tac-toe. I think everyone can go get a tic-tac-toe on their own. They want the tic-tac-toe. You can keep going after you've done the tic-tac-toe roll with me and to do so. Stand up when you think you know the answer. That is just equal 0. So we keep the equation. Stand up when you think you know the answer. Okay, boxes are super random. And we should put that at -3. Should be this one. Good job. And that's not the answer. That's only halfway. Both of those are only halfway. Which equals 0. We're going to finish the problem and graph them. Okay, let's do a graph, which is really good. Let's see the answers written. Should say x equals. So if those are the answers, let's say x equals that and x equals that. Okay, let's do. Actually, this is 0. And then we continue on. This way. they're both of those are there, or which they're close. Okay, so I'm factoring, and we need to complete the square. I think that's on the front side. Okay, 9 and 10. I gave you a cheat sheet box set, right? The pink, the white, what class was white? I don't know what class that was. Well, okay, you got your cheat sheet from last time. These are those back from these. I don't know what. The cheat sheet for water formula and complete the square. Now I have 3 of them. They told me. I don't know what. I'm good. Oh, here's a sec. That's smashing in the book. You don't have one. So, complete the square. You need to get this all set. Okay. Complete the square. The setup is different. Complete the square starts with what letter? Complete the square. Complete. C. So, completing the square should be equal to C. Complete the square. C. Complete the square should be equal to C. Meaning the variable on one side is a constant on the other side. Is this one equal to C? So on your little paper, does it equal a number? You want to change that number sign on step 1 to a C? They wrote this last year, and so I just called it a number last year. Because it's a constant is still a number. We need to get 63 on the other side, right? So 63, a constant with no variable. The complete square should be variables on one side, constants, or C, on the other side. Okay, so then how do we move the 63 so it's on the right hand side? Good, right hand 63. So we have b squared minus 18b equals 7 minus 63. Now I get 56. I put an arrow here so I remember the map, so I'll find out when to use it in another step. Number 2, if needed, divide everything by the leading coefficient. So how do we get 1 d squared equals 1 d squared? Yeah, probably not going to see that on the test, so don't worry about it. Number 3, find C. What's the formula? They have to quadrant formula, which is actually the Athens country. I don't know if it's easy math. B over 2. Because all squared, exactly. We can find C. Characteristics, divide it in half, and build it and create a square. Okay? So, what is our B? What is our B, Palmer? What is B for setup? Negative 18. So we have negative 18 versus, and divide them by 2. Don't touch your calculator. Do not touch your calculator. Negative 2 divided by 2. Negative 9. If you touch your calculator and stir it, you miss out on this number. This number we're going to see again. Negative 9 squared is 81. But that number, that's it. If you touch your calculator, then you don't have a hint to make sure you're on the right track. Step 4. Insert. Inserting. C, which is 81. So I go down to my line up above, that's all set up, b squared minus 18b equals negative 56. And I now add 81 on both sides. Look at the little green square. So now the left-hand side is a perfect square. By adding 81 of the green cubes into our picture, we're going to left-hand side, the next step, is to write your perfect square binomial. So remember we have b squared, and then we have 4x squared, 4x here. Originally, there were negative 18 of them. So how many of them are here? Out of the negative 18. There were 9. How many are here? Negative 9. And this is b squared. What's the width of the b squared? B. What's the length of the b squared? And here, we just put in 81 green tiles. So our length times our width is b minus 9 times b minus 9, which is b minus 9 all squared. As the perfect square binomial, that on your paper is step 5. Now the right-hand side is add like terms. Negative 56 plus 81, right? Can you do that for me? So it's like 81. That's awesome. It's like 81 minus 56. Double borrow. 1 minus 6. And then get. So 25. Alright, what's step 6? Solve for x. This usually takes 2 steps. So 2 things that you do. Move the negative 9, and then move the square. Right? How much are we going to move first? The negative 9 with a square. Let's try the inside. Let's look on the outside first. We're going to swap like Christmas birthday go on the present. Square root. Good. The difference in square root and square root. Those two cancel each other out. We must square both sides. And we apply the square root ourselves. So we have to write something. Plus or minus. Square root of 25 is 5. So now b minus 9 equals plus or minus 5. What now? B by itself, it's so close. What is b by itself? Add 9, but be careful while adding. There's a certain spot it has to go in. Does it go after the 5? It goes before the plus and minus. Because in order to add 5, you have something to add it to. So 2 problems. We have 9 plus 5, and we have 9 minus 5. Make sure you finish that. Don't just leave it like that. That's something to actually calculate. 9 plus 5, let's see what's 9 plus 5. 13. Okay. And 9 minus 5, I think what's 9 minus 5? This one. Those to be our x-intercepts, or the solutions for the value of b. So then we graph them. 1, 2, 3, 4, 5. 5, 1, 2, 3, 4. So a point at 4, a point at 14. Draw a parabola drum. They're equal. Yeah, sorry. Okay, good. Parallel. That's going to be the square. Bring this sheet straight to past. We'll see. Maybe the class next time. Okay, the next class is the test. I'm here after school today, and I'm here after school tomorrow. If you failed one of your quizzes we did last week, if you want to come in and make it up, we're actually making up quiz 10 during lunch tomorrow. You come in, work on quiz 10. If you don't show up on the first 10 minutes of lunch, work through it with me during lunch, I'll give you 100% on that quiz. So there's 0, or 1, or every 1 out of 10. Tomorrow during lunch, you have to be, if no one shows up in the first 10 minutes, otherwise lunch. You come in here tomorrow during lunch, within the first 10 minutes of lunch, and you work through and do reading problems similar to quiz 10, I will do 100% on that quiz, and you'll be more prepared for the test, for those problems are on the test. Bring up your calculators, please. Make sure you have your both test reviews next time, as well as you can do any notes you might have. And labor, you help by figuring out for school today and tomorrow.